Hey, Tim Koch with the Ashokan Watershed Stream Management Program. It's about 9 a.m. on August 5th, 2020, and I am standing in Birch Creek in the town of Shandaken, New York. Now yesterday, August 4th, Tropical Storm Isaias came through the area. Now thankfully we didn't see any large or significant flooding in the area, but this stream is definitely higher than it was at this time yesterday. This provides a good opportunity to discuss how streams react to rain events. By plotting the stream's discharge over time, we create what's called a hydrograph, which can tell you a lot about a stream. And right now, about 12 to 14 hours after the rain stopped from Tropical Storm Isaias, this stream is still reacting to that event. And we're on what's called the receding limb of the hydrograph. So let's take a closer look at a hydrograph and see what it tells us. When analyzing the hydrograph of any particular rain or storm event, the flow in the stream prior to the onset of precipitation is called the antecedent flow, sometimes called base flow. After precipitation starts, the flow in the stream begins to rise. This is called the rising limb of the hydrograph. It continues to rise until you get to the peak flow rate, or the highest flow that the stream sees in response to that event. On the other side of the peak flow point is the falling limb, or the receding limb of the hydrograph. This is when the stream flow slowly decreases over time until it gets back to the point where it was before the rain started. And at this point, the stream has stopped reacting to that particular rain event. So this is the hydrograph of the Birch Creek from August 3rd to today, August 5th. Now, one of the first things you might notice is that the rising limb of the hydrograph is much steeper than the falling limb. And that's pretty common. Now, yesterday, we got a lot of rain in a relatively short period of time, and so you'd expect to see a steep rising limb. But the flow that's passing me right now, the day after the storm, likely fell as precipitation miles away. It may have fell up in the mountains, where it took time to infiltrate into the soil. It takes more time to move through the soil and finally get to a stream channel, and then it takes time to move through the stream network. Perhaps some of this water started in a tributary, then it flowed into a larger tributary, and finally it flowed into Birch Creek, where now, 13 or 14 hours later, it's passing me. So that's why the falling limb of the hydrograph is almost always shallower than the rising limb. When precipitation data is added to the hydrograph, you see another interesting phenomena called the lag time. Now, lag time is the difference in time between peak precipitation and peak discharge in the stream. The lag time can tell you a lot about the characteristics of the watershed. In a forested watershed, where it takes time for the water to move through the forested landscape, through the soil, and into the stream channel, you see a longer lag time than you do in an urbanized watershed with a lot of impervious surfaces, and where storm drains move that precipitation to the stream channel very rapidly. Short lag times are also seen in the hydrographs of streams that have small watersheds, as well as those that have relatively shallow soils that don't have much water storage capability. Now, a short lag time is also referred to as a flashy stream, one that reacts quickly to a rain event. And in the Catskills, we are known for our flashy streams. So until next time, so long from the flashy Birch Creek on the receding limb of the hydrograph. And now to see if I can get back to my car without getting wet.